Now let us consider the topic which is composition and resolution of forces. So let us see what is there in composition and resolution of forces. When we consider force, it should have different components which are associated or which contributes to complete that particular action, right? So whenever we consider force, we should consider resolution of different components of forces. Forces, like other vectors, are represented by arrow, and it can be added using the familiar head to tail method, right? In the same way, like other vectors we can also add forces with the help of vector. Now for that we use the same method of head to tail or trigonometric method which we have used in our previous semesters or in our previous studies. Clear? So this idea was developed in vector. Free body diagram is used to represent various forces associated with the given body. So basically a free body diagram is a sketch which will show all external forces acting on that particular body or system. So what is a free body diagram? A free body diagram is basically a sketch which will show all the forces or all the external forces which are associated with that particular object or system. Now, the object or system is represented by a single isolated point. This is very important to remember that that particular body or that particular object is represented by a single isolated point, and we term that isolated point as a free body, right? And only those forces acting on it that originate outside of the object or system, that is external forces, will be shown on that particular body, right? We will only show all the external forces which are associated with that particular object. Now the force are represented by vector extending outward from the free body. So here if you can see in the picture, this is a body, so you can see here, right? So there are three girls. This particular girl is being given force by two other girls. This and this girls are trying to push this girl, right? So the force is in this particular direction from this girl and from inward from this girl. So once you do or once you observe it, you can easily be able to form a free body diagram. Clear? So it is very easy for us to form a free body diagram once we resolve all the component of forces. So for free body diagram, you can see here this is a force and there are two different forces coming out of it. Now, how problem solving strategies can be used for free body diagram, or free body diagram can be utilized for problem solving techniques? So there are few points which we must understand and must consider. So let us consider the first point. Draw the object under consideration. If you are treating the object as a particle, represent the object as a point, right? So what we need to do is we need to draw the object under consideration. We first draw the object, then if we are treating our object as a particle, then represent the object as that particular point. Place this point at the origin of an XY coordinate system. We should place it at origin of XY coordinate, right? Now, point number 2. Include all forces that act on body or object. right? We should include all the forces that is representing or acting on that object. Representing this force will be in terms of vector forces. However, do not include net force on the object or force that object exerts to the environment. We should not incorporate net force or any environmental forces exerted by the object, right? Exerted on the object and by the environment. Then third point is resolve all force vectors into x and y components, right? We should resolve all forces into two components. One is x component and another one is y component. Now we should draw a separate free body diagram for each object in the problem. So using these four steps, we can draw a free body diagram of any component. Clear? Now let us see here composition and resolution of force for this particular person sitting on the chair and working here, right? So you can see here the force acting on this particular person or student are due to chair, due to this particular table and the floor. So these are the three forces. Chair will apply force to this portion of the body. Floor will apply force to the feet of the body or foot of the body, and table will apply force to the hands of the body, right? So these are the three forces which are applied on this person, and earth gravitational force of attraction will work downward. Clear? So earth attraction will be working downward, that is gravitational force will work downward. Now in solving a problem involving the student, we may want to consider only forces acting on the line, right? So we should consider these two forces, one applied by the chair, another applied due to the gravitational attraction, right? So this is the free body diagram of this person. You can see here we should consider a linear force, a force which are acting on a line, right? So it is like this particular point. Now let us take one example associated with this. So here you can see example of a pulley system. A block on rest or a block rest on a table as shown here. You can see that M1 is a block of mass M1 resting on a table. A light rope is attached to it and run over a pulley. The other end of the rope is attached to a second block. As you can see here, this is the second block. The two objects are said to be coupled, right? These are coupled with each other. That is, block M2 exerts a force due to its weight, which causes the system to accelerate. This block will suffer an acceleration, or it will exert a force due to its mass, right? And due to that there will be an acceleration in the system. So now we assume that the string has no mass, so that we do not have to consider it as a separate object. If there is some mass which is associated with string, then we should consider string as a separate object, right? Now how we can draw a free body diagram for each of these blocks. So let us see. First understand there is one block M1 which is kept on rest position. There is one block M2 which is rolling over the pulley and attached to the other corner of this particular mass, right? M2 will suffer, or M2 will exert force due to its mass, and entire system will suffer acceleration equivalent to the forces, right? Now we need to draw a free body diagram for this particular system. So let us see how we can draw it. So each block will have acceleration or accelerate, right? So we can show them here. However, assuming the streams remain taut, That means it is not getting broken up. They accelerate at the same rate. So if a1 is the acceleration of body 1, then a1 is the acceleration for body 2 as well. Right, thus we can say a1 is equals to a2, that is acceleration of block m1 and acceleration of block m2 is equal. Why? Because they are connected with the same string. So if one block will move, other block will also move with the same acceleration or speed. Right, so if we were to continue solving this problem, we could simply call acceleration A. Now, two free body diagram should be drawn because we are usually finding tension which may require to use a system of two equations, right? So, here you can see M1 is having one force which is N, which is working downward, and M1G is working upward, and there is one tension due to string. In the same way, for body 2, the only force which is working upward is tension T, and the force which is working downward is M2G. So this is how you can draw a free body diagram for this particular system. Clear? Thus we can say A1 is equals to A2, that is acceleration of block M1 and acceleration of block M2 is equal. Why? Because they are connected with the same string. So if one block will move, other block will also move with the same acceleration or speed. Right? So if we were to continue solving this problem, we could simply call acceleration A. Now, two free body diagram should be drawn because we are usually finding tension which may require to use a system of two equations, right? So here you can see M1 is having one force which is N, which is working downward, and M1G is working upward, and there is one tension due to string. In the same way, for body 2, the only force which is working upward is tension T, and the force which is working downward is M2G. So this is how you can draw a free body diagram for this particular system. Clear?